Hello guys, so we are going to continue our discussion of retrieval augmented generation. In this specific video, we are going to discuss the core components of RAG. Already, at least we have understood till now, how does RAG actually works. Let's say I have a LLM. So let's say this is my LLM. And for this particular LLM, if whenever I provide an input, then I should be able to get the output, right? But in the case of RAG, what will happen is that these LLM are specifically connected to some kind of vector databases, right? Because in this vector databases, we store information in the form of vectors, right? So when this LLM is probably making a request to this vector databases, it will be able to get a response, and this response will be used as a context in the LLM to generate some kind of summarize output, right? Now, just considering this simple architecture, we really need to understand what are the important components whenever we're trying to design a RAG pipeline. So this is entirely a RAG pipeline, retrieval augmented generation. Now, if I go back to the diagram, which I have actually shown you, see there are three main important components which we have written over here. First one is document ingestion phase. Second one is query processing phase. And third one is generation phase. Okay. So these are the three main components. And if I probably talk about whenever we wanted to go ahead and implement this solution, we really need to talk about these terms. Okay. One is document ingestion phase, document ingestion and pre-processing. See, you know that we initially need to have some kind of vector database, right? And inside this, we need to store some kind of information. And this information will be coming from multiple sources, right? So if I want to talk about probably say some information in the form of vectors, obviously I need to have some kind of data, right? Some of the company's data, it can be some of the different data policies data it can be. So from external data needs to be there. You need to go there and store in a vector database. So the data can be from various sources, right? One of the source can be PDF, the other source can be from CSV file, it can be from website, right? And it can be from various sources, right? So we'll probably about talk about this. So initially what we'll do is that we'll read all this data from the sources and we'll try to probably create a data ingestion pipeline, and we also do the pre-processing so that we can store this in the vector database, right? So one of the core component of RAG is document ingestion and pre-processing, because here all my documents have how we are going to go ahead and ingest that data along with pre-processing in the vector database. That also we need to have a look at onto that. So if you probably see here, the document ingestion phase, there are multiple different data source files, right? So there are files like PDF, web pages, databases, right? And from this, we perform some steps. So in the document ingestion phase, we do splitter, we divide these documents into chunks. Why do we specifically divide? I'll talk about this when we go ahead. And then after that, we pass all this data to the embedding model. The embedding model's main aim is to convert this text data or any kind of data that is available over here into vectors. So these are nothing but these are the vectors. So here you can see these are nothing but these are vectors. Okay. So once this embedding models converts this chunk into vectors, then it is going to get stored in the vector database. Now there can be different vector database files, Pinecone and all. So to talk about the document ingestion and processing phase, what we do is that initially, let's say we have data, right? So this data can be my PDF data, it can be my document data, it can be document data, it can Word doc data, it can be website data, it can be different kind of data, right? How we are going to save this document into the vector database? So let's say this is my vector database. And why do we save this as a vector database? Because vector database means it stores all the information in the form of vectors. Some of the examples of vector databases are like Files, ChromaDB, data stacks. We'll all use all these things. There are vector databases like data stacks, right? There is one more databases which we most commonly use, that is called as Pinecone, right? So we'll be talking about this particularly as we go ahead. So in the data ingestion pipeline, this is the first step, right? I have some kind of data. For this particular data, what we do, we divide this into chunks. So let's say this is my chunk 1, this is my chunk 2, and the question arises, why do we go ahead and divide all this data into chunk, right? So let's say I have divided this data into, it can be any of this data, I have divided into chunk 1, chunk means smaller part, chunk 2, chunk 3. The reason we divide this data into chunks, so that, see, every LLM has a limitation of context size. Okay. Context size basically means how much LLM will be able to ingest that particular context and provide us some kind of summary. So say at the end of the day, whenever I make a pull or whenever I do search from the vector database, there will be some context coming up, right? If we provide less context, the LLM will be able to understand much more in a better way. The reason is very simple, because LLM also has a capability of ingesting some kind of content, right? Let's say if I say, hey, LLM, this is a book of 1,000 pages, you have to probably go ahead and have this book as a context and try to provide an answer, right? Now, some of the LLMs will be able to do this, some LLM will not be able to do this, because some LLMs will only have a capacity of taking a book of 500 pages as a context. But here we are giving 1,000 pages, right? So this is what context is all about. We'll discuss more about it. Every LLM has a limitation with respect to context size, because every LLM which been trained with different parameters, it has different kinds of capabilities and all. Okay. Now here we can see that in this first phase, when we first dividing data source into chunks, so that is nothing but it is done through something called as document splitter. So here we'll be using something called as text splitter, or we can also go ahead and use document splitter. Document splitter. Okay. Now once we do this particular splitting, then what we do? We go ahead, and this chunk is nothing but text, image, something, some kind of data it will be. Then we can convert these chunks into vectors. So here, let's say I'll be having some kind of vectors, and wherever we see vectors, let's say there is a sentence, we'll try to convert that into some vector form, that is numerical form. Let's say it will be like 0.6, 0.5, 0.4, 0.1, okay, zero point 0.7, something like this. So all this text will be converted into this kind of vectors. Now the question arises, how do we convert this? So for this, if you go ahead and see again this diagram, we use something called as text embedding models. Okay. So here we are going to specifically use embedding models, right? Embedding models. Now, embedding models is nothing but a task is to probably take a text and convert that into vectors. So if you have some knowledge with respect to NLP, I hope everyone should know what is text embedding, what is word embedding does. It takes sentences and it converts that into vectors. And this particular vector will be finally stored in your vector databases, right? Now, when these vectors basically stored into vector databases, you will be able to apply techniques such as similarity search, similarity search, Euclidean distance, and these are the techniques which will help you to find out similar kind of text from this particular vector database based on an input query, right? Similarity, so Euclidean distance, and there is also called as cosine similarity. So this is also one other technique that we can use, right? So that if I go ahead and probably pass an input over here, the input is what is, let's say, something related to this particular PDF. Let's say if I say what is an LLM, and in this PDF, this content is there related to LLM, then I should be able to, based on this particular input, I should be able to do one of these techniques like use cosine similarity and take out content which will be matching with the data that is related to LLM from this particular PDF, right? And from specifically, I'll be able to get the output. So in the document ingestion and pre-processing, this is what it happens. You know, this is what it specifically happens. And that is what we have discussed about. Very simple step. Initially, I will be having a data source. In the next step, we'll use document splitter, text splitter. What is this document and text splitter? What is this document? We'll discuss about this as we go ahead, because still we are not started our practical implementation. Then we convert this into chunks. Then each and every chunk by using embedding models, and again we'll be seeing the different embedding models, uh, both from OpenAI, from Hugging Face, so we'll also see from Hugging Face. They are super cool open source embedding models, which are actually helpful to convert text into vectors. And once we specifically do that, once we get the vectors, we can store that vector in our vector database. Okay. And whenever we give the input, we'll be able to do a similarity search and get the output related to the content that is available over here from the different data sources. So this is all about document ingestion and pre-processing. Now, in the next video, what will happen? See, this vector database is ready now. So this is the pipeline that we have discussed about it over here. This is a complete pipeline that we have discussed over here. Now, and this pipeline is nothing but data ingestion and pre-processing. Now the next thing is that how LLM takes an input, how does it query, and how we get the context. We'll discuss about that in the query processing phase. Okay. So let's go ahead and discuss about this in the next part. Thank you.